In this section, we'll be looking at compound interest and how we can model compound interest using exponentials. Let's go ahead and set up the equation for compound interest. We're going to let P be equal to principal throughout the section, and principal is going to be our starting amount of money. I is going to represent interest rate per time period. And the other common object that we're going to be looking at is amount of money gained per time period. So this is going to be our principal times our interest. If we add our principal along with the amount of money gained with interest after one time period, we're going to get the total amount money gained for that given time period. If we wanted to go ahead and reinvest this money again, then we can use this formula recursively. So our new principal, if we apply it to this formula, is going to be given by, again, P plus PI. This is our new principal after reinvesting our money. Let's go ahead and rewrite this equation real fast as T is equal to P times 1 plus I. Well, if we apply our new principal to this equation here, this equation is going to transform to be T is equal to P plus PI times a 1 plus I. And the reason why is because we replaced this P here with our new principal. Factoring the P out of this term here, we get P times 1 plus I raised to the second power. We can go ahead and reinvest our money into k different time periods. Doing this recursively, we're going to get the total amount of money is equal to P times 1 plus I times k. Here we see that we have an exponential now, given by this term here. Now, I is going to be the same thing as the annual interest rate R divided by the number of times per year we've reinvested, which is going to be N. And so we're going to call the number of times we reinvest per year compounded N times per year. So this is going to be equal to R divided by N. The number K represents the number of times we've reinvested. So K in this case is going to be N, which is the number of times that interest is compounded per year, times the number of years. Rewriting this formula of total principal gained, this is equal to P times 1 plus R divided by N times K. So let's go ahead to the next page and just summarize what we've just determined. Compound interest is modeled by the following equation. A of t is equal to P times 1 plus R divided by N raised to the N times t, where we're given that A of t is going to be the amount of money obtained after t years. P is our principal. R is the interest rate per year. N is the number of times interest is compounded per year. And T is the number of years. So while compound interest is given by an exponential, let's just recall where we started, and that was simple interest. Simple interest, again, is given by P times 1 plus our interest rate. Oops, sorry, I realized that this shouldn't be an R, but this was an I. All right, let's look at an example. This is going to be the last example in the section, example number 5. And we want to go ahead and find the annual percentage for an investment that earns interest at a rate of 6% per year, which is compounded daily. So the first thing that we should note is, let's go ahead and look at the first equation. We have A of t is going to be equal to our principal times 1 plus our r divided by n divided by, raised to the n times t. And let's go ahead and decipher what they give us here. Our interest is going to be compounded daily, which means that n is going to occur 365 times. And we also know that our r in this case is going to be at a rate of 6% per year, so this is going to be equal to a 0.06. We can go ahead and plug these numbers into our equation, and we're going to get that this is going to be p times 1 plus 0.06 divided by 365 raised to the 365 times t. What we're looking for is we're looking for this annual percentage. So our time period, t, is only going to be 1 year. T in this case is equal to 1. Our equation number 1 is then going to be equal to p times 1 plus 0.06 divided by 365 raised to the 365. Simplifying this using a calculator, we're going to get that our parentheses 1 plus 0.06 divided by 365 raised to the 365 is going to be equivalent to 1.000164 raised to the 365. And raising this term to 365, this is going to be approximately p times 1.0618, so on and so forth. Let me go ahead and start a new page. What we found was that our A of t is equal to p times 1.0618. Recall the thing that we're looking for is the annual percentage for an investment. This is going to be given to us equivalently by our simple interest formula. This is given by p plus 1 plus I here. So writing this term out, this is going to be equivalent to p of 1 plus 0.0618, which means our annual interest rate is going to be about 6.18%.